Okay, so this is our multifunctional car. So in order for this car to move, we have an H-bridge motor driver that we have 4 motors that control each of the 4 wheels. For each motor, we have a positive and a negative. These positive and negative wires for each motor has 2, the positive and the negative. For the motor driver, we have 4 inputs. The first input takes 2 positives from two wheels, 2 negatives from 2 wheels. The other one has from the other 2 wheels has 2 positives in one input and 2 negatives from the other input. So this is from the motors. So what do we take from the motor driver? We take 6 pins, okay? So we take 4 inputs. They are 4 digital inputs. They are placed from 33 to 39 I/O pins, 33, 35, 37, and 39 respectively. Then we have 2 enables. The 2 enables are the PWM pins. The PWM pins are set for 12 and 13 in order to increase and decrease the speed analog, not digital. We have our car running at 150 speed, and then we place the car on a black lane. See, the lane stays the same, okay? Because the color sensor detects black. If we leave it, now it says it has a different lane.
This is the simulation of the mirror in the car. A joystick is used to control the servo motor. The joystick is moved left or right and takes in inputs from analog inputs and to the Arduino board. If the values are less than 300, it moves anti-clockwise, and if the values are more than 700, it moves clockwise.
Assalamu alaikum. For the rain sensor, it always displays on the LCD dry weather, but when we put some water on the rain sensor, it displays on the LCD that it's rainy. When the water level sensor is not in water, the LCD shows that the fuel is low. Otherwise, it shows that it's average fuel or full tank.
It's all done
When it's not in the water, when it's average way into the water, it shows the average fuel. Otherwise, if it's not in the water, it shows low fuel.
Divided all of our features into 5 tasks. The first task is the highest priority task, and it controls the driving the car. The second task and the fourth task are both the same priority 7, and it's the second highest priority. They're concerned with the fuel and the color and the lane detection. The third task is concerned with the seat belt, the rain, and the servo motor, which control the power mirrors. The last task is the RFID task for starting and stopping the engine. They're all periodic tasks, and they're separated by delays. This is the RFID. It's set to SPI mode, which is 01. And once we swipe the card, the keychain, it authenticates. And then when it authenticates, we have to press this push button, which is the start-stop button, and then the car starts. As we're gonna see here, when we authenticated and we started the car, first off the LCD started and the whole car started. And then to stop the car again, we swipe the key again and we press the stop button. authentication, the start stop is set to 0, and then when we look at the LCD here, everything is cleared and the car is stopped. In order to configure the RFID, we need to include the SPI library and the @root library PN532. Then we need to write NFC begin, which starts the near field communication. It then gets the version of the near field communicator, and once it detects the chip, it sends a message that it found the chip on the serial monitor. And then once we configure it, it can then authenticate the keychain that you have in order to start the RFID. Once it found the chip, okay, it then reads the data on the card or the keychain. You can either use this keychain or a card. And then here it authenticates it, and it checks that it is the right card. And if it's the right card, then we delay for 500 milliseconds to allow the user to press on the start and stop button. When the button is pressed, then the flag is reversed and the car is started again. Once the car is started, we give the semaphores so the other task can start.